I believe, and I don't know about you, Dave, but I believe that there's a misconception about the IV and what it does and what it can do.
Yeah.
I believe that a lot of people think that the IV is the machine that actually does the testing, when it really isn't. The IV is just a vessel.
A vessel.
It's just
Isolation vessel.
It's just an accessory that facilitates the testing.
Correct.
But the testing is actually done by the HYDROS. Hey everybody, welcome to another episode of CVTV Podcast. My name is Carlos and I'm here with David Dockin, owner of CoralVue, and my co-host. How are you, Dave?
Doing well, Carlos. How are you today?
I'm doing well. Back home, from all the trade shows. We got one to go. I know that.
One to go.
One
to LA shortly, and that'll be a wrap.
Yes, exactly. Yeah. It'll be a wrap after the wrap. We're going to talk about one of the most used accessories in the HYDROS world, and that is the IV. And I know this. I want to talk about it because we have a new version of it. Actually, It's called the IV Pro. And let's see, what are the differences between the IV and the IV Pro? Because it's a brand new design, and it's actually kind of sexy looking.
Yeah, absolutely.
Yeah.
It looks pretty good. So one of the biggest things I like is it comes with the little door on the front.
Yes.
And, during this whole testing phase we went through with doing this, mine sits in a room with lights on, and I was noticing a film that would build because there's always water inside. And I'd have to keep cleaning it because the film would get in the probe. But then I noticed if I kept that in the dark, I didn't get any film. So we include in this nice little door that comes on the front.
Yeah, it shields the water sample and the wet surface inside the glass from the ambient light. And unlike corals, algae grows with pretty much anything.
Yeah,
corals don't, but algae, you put a candle right next to it, it'll grow algae for some reason. Algae is just that way. So it shields it from that light, preventing it from getting all gunky and algae growing inside. Another thing that I like about it is the different colors. It doesn't do anything to the testing, but it looks good. It looks good. And if you notice, for those people that have it, if you don't have it yet, you'll notice that in the parts with the parts that come included with the IV Pro, we no longer send O-rings to hold the pH probe and the conductivity probe in place. And that's because the hole where the probes go, it's made out of this plastic, softer material.
Almost like a rubber.
And what it does is it actually gives a little bit, it contracts. So when you put the probe, it's almost like it's self-gripping.
Yeah.
Yeah. So you don't have to worry about it.
You set the height right from there. No O-ring or anything to set.
No, it just sets it in there.
Simple.
It makes it very simple. It also, that material is on the lines in the back that go from the reagent line, the fill line, and the drain line, because I've had issues when I'm trying to calibrate my probe, and I grab the probe out and I'm calibrating, I put it back in, and when I grabbed it out, I probably, with my knuckle or something, I pulled out some of the line, and then I'm getting strange readings, like really high readings. I'm like, what's going on? And then I go in there, it's like, oh crap, I pulled it up, so I have to push the thing back. With this self-gripping material, those lines, they're secure there. You have to go out of your way to pull them out. I noticed that too. Another thing that we've done is that the motor has a new base, and the base is constructed in a way that if the water were to overflow for whatever reason, the drain pump got clogged up. It happens. It happens. The drain plug got clogged up, so water's going in, nobody's going out, and all of a sudden it starts to overflow. The new design actually makes it that water does overflow, but it never touches the motor, so you don't have to worry about the motor being exposed to water and burning out. So
Yeah.
that's a new design that we have in there. And material, I think, is
Yeah.
sturdier. I
Yeah.
think it is. And the mounting bracket in the back,
Hmm.
it's a vertical mounting bracket, so you don't have two set holes that you can't that you so you only have two positions. Now you can actually you can move it up and down however you want, which is kind of
Yeah.
nice. It's very nice. But you can also put it on a table or a flat surface and it'll work.
So yeah, just some nice little features, we've tried to improve on, and also in including that glass probe. I think the combination of the two makes it a nicer overall product and
Yes.
a user experience.
Yeah. So okay. Now, technically don't need an IV in order to do
Hmm.
alkalinity testing.
You can perform an alkalinity test without, having an IV and investing in that. Um, you can actually do it off drive ports.
Mhm.
So there is, other options. We give the software away. Is basically what it is to
Mhm.
perform the test.
Right. I mean, but if you're not investing into the IV, you would have to get 3 dosing pumps,
Yep.
and one of the dosing pumps has to be very low speed because it has to be able to dose 3 milliliters per minute. In
Hmm.
addition to that, you have to have some kind of contraption that can hold the pH probe and the conductivity probe high enough so they're not just sitting on the glass, because
Right.
that also affects it. And on top of that, you would have to find a mix a little motor with a coated mixing magnet that you could plug
Hmm.
into an outlet, or it would have to be 12 volts in order to do that. So I mean, yes, you can do it, but
You could do it.
you could do it.
Yep.
You could do it. If you work in a lab, you probably have access to all this.
Yeah.
But if I also worked in a lab, probably I wouldn't be using the IV for testing alkalinity. I'd be using something
Yeah.
else.
Yeah.
Let's talk about the conception of the IV, because we never actually talked about how it all started
Yeah.
and why did we end up doing an isolation vessel.
Yeah. I mean, basically, we needed a way to perform this titration. It's an acid based test. We needed a spinner. We needed a way to agitate or spin the reagent as we drip it into the beaker that we have, and then it would needed a way to hold a pH probe in order to then make the measurement. And the measurement's based on how many drips and the pH. As the
Mm-hmm.
drips drop, the pH lowers until it gets to about 4.5, depending on the type of test you're running. And then it gives you uh, a, a number, an alkalinity number based
Mm-hmm.
on that. So that was the
Yes.
whole reason behind, this isolation vessel IV, if you would. But I think in the process, we've learned some things, and we've also learned about the pH probe themselves, and the different type of pH probes.
pH probes are built differently.
Oh yeah, there's
It
so many out there. You would just you would not believe the selection and the different types of pH probes.
The IV Pro includes an IV a pH probe like the IV, the regular IV, the first generation IV. But the difference
Hmm.
between the first generation and the Pro version is that the first generation had a plastic probe. This new version comes with a glass probe. Now, Dave,
Yes.
what is it that we found out? Why are we making the switch from plastic to glass when, in as a newbie, as a hobbyist? Wait a minute, it's like they're so delicate to begin with, and you're giving me a glass probe. If I look at it wrong, it'll crack. So why
Yeah.
are you giving me something like that? So I want to know the
Yeah.
reasoning. We want to know the reasoning behind why are we going to a much delicate probe.
So basically, when we perform this test, we're using an acid. As that acid drips into our beaker or collection container, we are lowering the pH value. With a glass probe, we're able to see that and define that drop much more rapidly than we can with a plastic probe. This in turn gives you a greater accuracy.
So it has to do with the response rate. So the glass
Yes.
probe is far more responsive. They're both good.
Yep.
And the plastic is just as good as the glass probe, but in this application, we want to get that response. We want to get that pH number as quickly as possible
Correct.
before we
Before the
add
next
more
drop.
acid.
Yeah,
Yes,
correct. Yep.
exactly. So that makes it more that in terms turns into a more accurate test.
Yes.
Okay, so that makes complete sense. I mean, it's like something that most people don't even think about it, but it
Yep.
makes sense. And the glass probe, also the glass probe, it's completely 100% glass, which
Yep.
means that there's no seals, there are no gaskets, nothing that salt water with time will corrode, and eventually either the liquid inside the gel inside the probe will leak into your tank, or vice versa, the water from the tank will seep into
Hmm.
the probe, causing the probe not to work and not to work correctly. Also, I know that we've noticed that the glass probes last way longer
Way
than the
longer.
plastic.
Yes. Way longer. I also like to mention the ease of cleaning compared to a plastic probe. I mean, they're super simple to clean. And I don't know for whatever reason, Carlos, but I noticed on mine with a plastic probe, it tends to get like a little gunk or some black film that would build up at the very base of the tip of the probe, almost like it's going into it. With the glass probe, I really don't see that. And it's so simple to clean. It's almost just like wiping it.
It's
You know?
almost like whatever that gunk or that organic matter is attracted to that seal, that little gasket
Yes.
between the little bulb and
Yep.
the plastic body.
Plastic.
And it just
Yep.
on the plastic probe, it just goes right there, and then you
Mhm.
have to clean it more often. With the glass probe, you don't have that gasket or that seal,
Yep.
so it doesn't happen. I've noticed. I mean, it does get a film in it because bacteria grows around it, and
Sure.
that's sure. But you just have to grab a paper towel and very gently just wipe it, and you're done. It's
Yep.
quite easy. So that's great. I mean, so that's the big thing. Yes, it is more fragile, but we believe that the benefits of a greater accuracy in testing outweigh the fragility of the probe. And honestly, once you put it into the vessel,
You're
you
not going to
really
touch.
you're not going to move it. There's not going to
Right.
be anything in there. All right.
Yep.
So another thing that I know that we stumbled upon when we were creating the IV was the conductivity, because I know for a fact that when we started the process, we didn't even think about conductivity in the IV. It was halfway through the process. We're like, wait a minute,
Mhm. Right.
why is that? Why was that?
Well, we thought, since we have this vessel, why not use conductivity, a conductivity probe to take a measurement within this vessel, isolate it from the sump, isolate any noise of pumps or anything that could provide electrical noise, get it outside the tank or the sump, and put it in this isolated vessel. That's going to give you, in our opinion, what we've seen is the best, most accurate result.
So I'm going to play the part of a newbie here
Mhm.
and ask you, but what's the problem with the why do I want to isolate the conductivity? Why can't I just put the probe in the sump with all the other stuff? What
Sure.
happens?
Yeah, you very well can do that, and maybe you'll be fine. But we've noticed, all these pumps and heaters and all these type of electrical devices, lights, they all create electrical noise. Some is more prevalent than others. Why we don't know. We can't see everybody's system and how it's wired and that such thing. But electrical noise is a big thing when it comes to these type of probes, and we could see a variation and an inaccuracy in conductivity with a lot of electrical noise in the environment. So getting that away from that and isolating it was a huge improvement. And I've actually seen some other devices on the market now. People are coming out with, Carlos, to try and simulate that same thing that we're doing. I don't know if you noticed that, but
Yeah, I have, and that's conductivity has been a thorn in the hobby for many years because has never they had never been a way to do it reliably. So,
Mm-hmm.
like Dave said, like you said, you had some people that had no stray voltage at all, and you put the probe in there and it works perfectly. They don't have any issues. And then there are the people that have some type of stray voltage, and then all of a sudden the readings go up and down. You couldn't figure out
Yeah.
why. And people were
Mm-hmm.
saying, well, it's the probe is getting dirty and all that. And some people were saying online, well, I've never had any issues with it. And other people
Yeah.
say, well, it doesn't work.
Mm-hmm.
And after doing the research, we figured out they had to do with the stray voltage. And knock on wood, in the years that we've had the IV out, conductivity interference is the least support inquiry we have.
Wow.
I can tell you that. I cannot remember the last time a customer submitted a ticket to CoralVue that I've seen asking for problems with conductivity.
Mm.
Once that probe is broken in, and
Yeah.
it does take
It takes it.
about it takes 2 to 3 weeks to break in, and we tell you
Yep.
that it's on the instructions. You have to be prepared 2 to 3 weeks where don't touch it, don't calibrate it, don't even look at it, because all it's going to do is it's going to raise your blood pressure
You're right.
for no reason. So just
Yep.
leave it there. 3 weeks later, go ahead and install it, and you'll have no issues. And once
Yep.
they do that, it is pretty much spot on all the time.
Mm-hmm. Mine never moves. I'm just like, I'm so
And it,
excited. You know, it just,
and
it
it
doesn't move.
shouldn't
It's just,
and it
it shouldn't.
shouldn't move. It shouldn't
Yep.
move unless something really bad happens or your ATO
Mm-hmm.
goes crazy. It really should move, because even
Yep.
with evaporation, your salinity is not going to swing all this just
Correct.
overnight. Yeah. Yeah. So okay. Now I do want to talk about the IV and the upcoming Maven,
Yeah.
because during the trade shows we get this question asked a lot. And
Mm-hmm.
you know, I am, people come over and says, "Hey, Carlos, hey, Dave, it's like, hey, I love what you guys are doing, the innovation. You guys keep coming out with products, but I just purchased the X10 and the IV, and now you're telling me that the Maven's
Yeah.
coming out. So, you come on, it's like
Yeah.
I'm gonna have to sell the X10 and the IV because I have the Maven. I don't need the X10." And I'm like,
Yeah. Yeah.
wait a minute. They're two different machines, and
It's two different animals here.
two different animals, and they're both right if you use them in the correct application.
Yes.
And the key
Yes.
word is the application. So let's talk
Yeah.
about that, Dave. What are the
Yeah.
two different applications?
When I first saw it, we released a Maven, and I saw the comments. You guys just came out with this IV and X10. It was almost like some angry comments, and I'm like, wait a minute, we need to back up here and talk about the different applications, and the cost is a
Mm,
big thing, and what it's going to take to perform alkalinity testing with a Maven versus an IV.
mhm.
And the application is basically how often are you testing alkalinity? For me personally, it's every 4 hours. Um,
If you
so
chase
then,
numbers, if you're a
yep,
numbers chaser and you're 2 hours, 3 hours, 4 hours,
yep,
compared to testing once a day.
yeah. And some people are like, "Oh, that's totally unnecessary," and I'm like, I I have a tank loaded with coral. I can show you the alkalinity shift hour by hour.
I mean,
It's real, and
it
I
it's
have to.
fun. Go
Go
ahead.
ahead.
Sorry. No, go ahead.
No, you have to perform the test, and those decisions of the test is based on what my calcium reactor is going to do.
It always cracks me up when people says this is unnecessary, and it's like, yes, it's unnecessary to you,
Hmm.
to you. as a person,
Yeah.
yeah, but you can't speak for everybody else around you because everybody else is different.
Yeah.
So, that's the one thing that as a manufacturer, we have to think. It's like we can't think of a single person. We have to think of a group of people, and we have to figure out a way to make it work to everybody. That means the person that thinks it's unnecessary and the person that thinks that it's required.
Yeah, absolutely. And that kind of defines the reason for the two, from an acid based test, which, we can get into discussing. We talking pennies per test, Carlos. I mean, you've run some preliminary numbers before this versus a reagent, color shifting reagent based test with the Maven.
Yeah, we
And
did some numbers about this, and the IV. Let's say you purchase 1 liter of concentrated reagent from CoralVue. That'll, in your alkalinity is around 8 DKH.
yeah,
That'll render you about 350 tests. And the liter of reagent is $20, which comes out to about 5 to 6 cents per test. That's 5 to 6 cents per test. Okay.
yeah.
Compared to alkalinity on the Maven. And we don't have the pricing, but let's just say the alkalinity in the Maven is going to be the same price as the aftermarket reagents sold for the other comparable machines to the Maven. You're talking about the test per test would be around 50 cents.
Yeah.
So the IV is 1/10 the price of the other testing machines out there that can also do calcium, magnesium, and all the other elements.
Yes.
So if like you said, going back to your point, if I'm testing twice every 2 hours, that's 12 tests.
Mm-hmm. A
If
day.
it's 5 cents, that's that's a no-brainer. But 12 tests at 50 cents each with a 100 limit before I have to. Once you reach 100, you have to go and get a new reagent.
Yeah.
It'll add up. So the application is, if you chase numbers and you're the kind of person that wants to have that alkalinity reading every 2 hours, the IV is the testing machine you have. If you're the kind of person that wants to test once a day, then the Maven will work just perfect, just fine. So the IV Pro is the second generation of the IV, the accessory for the HYDROS, and it'll allow you to test alkalinity on a frequent basis. It'll also isolate the testing on conductivity, which is great. You want to do that. So I think that this show will serve its purpose. I hope that people understand our reasoning behind the changes. And we are not making changes just because we want to sell you something more expensive. There's actually a thought process to there's a method to the madness, as they say.
We always going to want to improve on what we're doing, and it's certainly if we can, we want to be able to offer that.
Absolutely. So we want to say thank you to everybody for listening to our podcast. Again, you are listening to CVTV podcast. We do this on a weekly basis. I like to say that we do it every week, but it's kind of difficult sometimes, especially during travel season. But we try to. And if you stumble upon this podcast, that's great. Hit the subscribe button. If you are watching us via YouTube because you like to see our beautiful faces, then you can also listen to us. Just go to Spotify and search for HYDROS or CV CoralVue, and then you'll be able to listen to us on your drive, your ride, your commute to work. Anyway, so I'd like to say thank you to our listeners. Thank you to our watchers and viewers. We appreciate the support. Thank you, Dave, as always, for being.
I appreciate you, buddy. So
for allowing
always good.
Always to have these conversations. I think next time we do a podcast, we're probably going to be doing it in person in California.
Awesome. Looking forward to it.
Yeah, it'll be fun.
Yeah.
So thanks again, everybody, for watching, for listening, and we'll see you next time.